So my name's Ian. Yes, I am very much an F#aholic. What we're going to cover tonight is basically three sets of things. So I've split it into three sections. So we're going to do a getting started section, then a look at web programming, and then we'll have a look at how we're using F# in production and give you an idea of what it's like. Because obviously you've probably not spoken to many people or heard from many people who've actually got F# in production. So it'll be might be quite interesting for people. So the first thing to note is that F# is a general purpose programming language for the .NET platform. I have to say that. There's an awful lot of noise out there about what F# is and isn't. It is a general purpose language. Virtually anything you can do in F#, in C#, you can do in F#. So there are some differences. So there are some things that are designed for C# more. So a lot of the UI technologies and things like Entity Framework certainly work better with C#. But apart from that, F# will do virtually everything. Join the F# Software Foundation. So that's the community behind F# in effect. So there's a great Slack channel there as well if you join the F#, if you join the Software Foundation. So there's been a change in the last month or so. Previously on the front page of the fsharp.org, it used to say functional first programming, but now we don't say functional first programming. We say that it empowers everyone to write succinct, robust, and performant code. So I'm going to try and cover both within all of this. So hopefully you'll see that it's a really nice language to work with. I love it. So I will apologise if I diss C# at all during the session. It's not intentional. Well, it might be intentional, but C# is a wonderful language. It's just I prefer F#. So let's get started. So we're going to start off with a simple use case. So those people who've read the book, this is fairly similar to the opening chapter in the book, but it's slightly different. So we're applying a discount. So eligible registered customers get 10% discount when they spend £100 or more. And we've got some criteria and some examples. And what I've done initially is to create a simple record type, which is this thing here. A record type is not quite like a record type in C#. They are very different. So a record type is just it's effectively a simple bag of data. It can be much more, but fundamentally it's designing a structure that you're going to supply all of the data for. So this customer, when you create it, you have to supply a name, which is a string, an email, which is a string. I'll come back to option in a second. And then you've got a couple of bulls for eligible and is registered. It's a really simple example. It's not perfect, it's deliberately not perfect. So the option is how we try to handle things that are optional. So we don't use nulls in F#, we use the option type. I'll explain what the option type is in a little bit more detail as we go through. But at the moment, all you need to know is we don't use nulls. It's to say you could have an email or you might not. So what we've then got is a simple function called calculate order total, and that takes two parameters, customer and spend. And if you look just to the right of that, you'll see I haven't done this. This is this customer arrow decimal. That's the IDE actually working out what the type signature of that function is. So this is not dynamically typed. It's strongly typed, just like C# is. All of .NET is strongly typed, but you don't need to specify types against a lot of things. The compiler can infer the types of a lot of this. Now you can, if you want to, go through and add the types in there if you want, and some people do that, and it's fine. But it's nicer if you don't. I think it's a little bit cleaner. if you don't. You'll also notice that they are separated. They're what they call curried parameters, rather than tupled, which you'd normally see in C#, where you have the commas in between the parameters. Technically, there's no real difference between the two. You can use both styles, but there are some technical advantages with F# to use the curried style, as we'll see later on. So it's a simple function that takes a customer and a decimal and returns a decimal out of it. So the first thing that we do is we work out what the discount is. So I can dot into the properties of the record type. So customer.is registered and customer is eligible and spend greater than whatever. Then you return that. Otherwise you return this. And then I do a simple thing at the end, which is spend minus discount. No return, very few brackets, or almost no brackets there. You don't need semicolons at the end of lines. They're optional. Most people don't bother because it's not worth it. So that last line, spend minus discount, automatically gets returned. So whatever the last item is in the last expression gets returned. And then I've created some instances here. So I've used the data that's in the example above. So I've created John, Mary, Richard, and you'll notice there's Sarah as well, who's not one of our registered customers. So I've created these. So John is, so name John, email is, that I'll explain what that is in a second. And then is eligible is true and is registered is true. I can create Mary by using John and just changing the bits that are different. So exactly the same as you can do with .NET, with C#9, I think it is. You can do this with. I think that's the one that you can do it with that. So I've created four customers, and then I've created some simple tests. So I can, just like C#, I can write full tests, but what I'm going to do is I'm going to run the code in the REPL, actually here. So this is an FSX file, just a script file, but this is exactly the same code as I'd use in production, maybe. So what I can do is I can highlight some code, and I can press Alt and Enter. And what this will do is it will run it in the REPL for me. So we look at the bottom of the screen. So I can now run the rest that I need to set up. So I create the function and the people, and then I can run my asserts, and they all work. Yay! Go in. So this is very different from the style of coding that you do with C#. You know, there's a couple of things to remember here. Number one, the order of the code matters. So if I move the customer type, if I move that below the calculate function, it doesn't work. So things have to be, it's a bit like JavaScript. You have to have set the thing up. You have to have actually, the compiler has to be able to pick it up before you can use it. So I'll undo that before we go break any more. So that's a simple one, right? So I said the option type. So the option, because we don't have nulls. Technically we do have nulls, but we don't use them. In normal F# code, you should never use the word null, or unless it's absolutely necessary. But that shouldn't happen very often. So because it's an option, what we have for option is, this is actually built in. So although I've got the code here for type option of T, so it's a generic type, and it returns either some of whatever that type was or none. So in the case of an email address, it's a string. So it's some of a string, so some of an email address, or it's none. So here for John, I've got some of email address, same for Mary, and for Richard, I've got email equals none. So that's what we do to begin with. That's a nice start, but there's some real problems with this. Number one, I don't like bools for describing business functionality. What I want to do in this case is I want to in particular, I want to make registered a thing. So that's where I'm going to start with this. So if I can, sorry, I've got the little thing in the way, the tab for the Zoom. So it's exactly the same problem, but what I've decided to do is to create a registered customer and an unregistered customer. So two records, one to cover one case and one to cover the other. So registered customer, I've got the name, the email, and the is eligible. So that matches pretty much what we've got in the requirements when we started. And for unregistered customer, I'm just going to take the name. Now, a customer, so I need to be able to use the same function. A customer is either a registered customer or an unregistered customer. So what we have here is a brand new type called customer, and this is a discriminated union. It's a really simple idea. So the customer is either registered of registered customer, so either has that sort of data, or it's a guest of unregistered customer. So the registered and guest are effectively constructor names. They're case names technically, but they're basically constructors. So you can call them whatever you like. So they don't have to match what follows. So in this case, I've used guest and unregistered. I could have said registered and unregistered, but it's just to show you that, that they can be different. So what difference does that make? Well, I'm going to move things around a little bit here. So the first difference it makes is to the instances of the customers. So John is now registered and a registered customer. So I've created a customer by using the same structure as I have for the discriminated union. And for Mary, it's the same. And then for Richard, it's basically exactly the same, except we've got is eligible is false rather than true. And then Sarah is a guest with just the stuff that we need for unregistered customer. So you'll notice on the right-hand side here, where we've got where the compiler's worked out the types, they're all customers. So they're not registered customers, they're not unregistered customers, they are customers. It just so happens that one is that some are registered and some are guests. So that means that this function remains pretty much the same, except the logic changes. So now when we pass customer in, I can't do customer dot, because it doesn't make any sense. Because the data that's attached to a customer is either a registered customer or it's a guest, and they've got completely different data. So you can't use the same, so you can't dot into things. What we need to do instead is to use pattern matching. So use a match expression. And what I've done here is to say match the customer with it's registered. The C here is an instance of that registered customer. So it's pretty much exactly the same as the pattern matching you get in for types in C#, but it's a lot more. What I'm showing at the moment is fairly simple. They get a lot more powerful than this. So I say that registered customer when it's eligible and the spend's greater than 100, then return that. But why have I got the second one? Well, let's remove it. You notice I now get a squiggle underneath our yellow squiggle? So it's telling me it's an incomplete pattern match. So a discriminated union is a closed set. So you must in a pattern match everything that's in the discriminated union. So the first case, I've covered some of registered, but not all of them. So I need to have a second row in there for registered, and the underscore is exactly the same as C#. It's for, we don't care about it. So that has now covered all of the cases. I can, if I want, just use, I can just do that. Problem with that is that if I add a new type to customer, that it doesn't get picked up by the pattern match. The pattern match will automatically cover it with the wildcard. So sometimes you're better off leaving the structures in place. You can make it slightly simpler. I can remove that. And that just basically, so that says anything, it just drops down and picks up the last value. So again, what I want to do is I'm going to run this. So if I run all the code that I've got, it's running inside the inside there, and I should be able to just run the asserts, and everything still works. So I've made it slightly better. That's slightly more readable. I hope you all agree that that's slightly more readable than the previous version. There's also, you also can't get a situation where, in the previous example, it was possible if you missed the, to make somebody eligible and not registered. So we can't do that now. But we've still got a case of, I've still got eligible in here as a bool, and I want to clear that away as well. So I'm hoping everybody can see that still. Right. So I was talking to the PM of this, and they said, well, actually, eligible registered customers have to have an email. So how do we solve that? Well, most of the time with these sorts of problems, the easiest way of solving it is adding another type. So that's what we're going to do here. So ignore the top two for the moment, ignore the email and customer name. So we're going to add an eligible registered customer with a name and with an email that's not an option. And then we've still got registered customer, and we've just taken off the is eligible flag, and unregistered remains as before. And now for customer, I've now got three types. So I've got eligible of eligible registered customer, registered of registered, and guest of unregistered. They can use the same data. They can have no data. But in this case, we just happen to have different types of data against each of the cases. So at the top here for email and type and customer name, they're simple aliases. They don't actually do anything other than they just make the code a little bit more readable. So we can go a lot further than this, and it's beyond where we're going with this particular talk. But yes, we can do things like emails have certain structures. So we can allow emails and not allow other emails. And customer name, it may be that we make it, say, 50 characters. But we can't do that with this. This is just a simple bit of making it nice and easier to read. So a name is now a customer name, an email is an email. But we're not actually doing anything with it. So again, changes to this. We've now had to change the eligible customers to eligible, and we've got less data with it. But they're still customers. So all of these four customers are still of type customer. So they're still using the discriminated union. So it's still one of those. And they're all structured exactly the same way. So it's the constructor name and the type of data that goes with it. Exactly the same. And it now simplifies the match expression a little bit as well. And I've decided there just to use the wildcard, just to say for everybody else. And if I run that, again, using that should all work. So that's that's a simple use case, working it through, making it a little bit more readable. I think we've got something a little bit better than we had before. I certainly like this. I certainly prefer this to the original version, which was this one here. So one of the things that we try to do with F# is to make it so that illegal states are unrepresentable. So we try and make it so that the compiler stops us doing lots of bad things. If the compiler does that, then it means that we don't have to write tests for it. If you can't do it, you don't need to write a test to stop it happening. And I'm all for not writing extra tests unless I have to. So there are two of the main types that we use. So we use record types and discriminated unions for all of this. So I haven't mentioned a few other words that I probably should mention at this point. All of this is immutable. So we haven't modified any data. What we've done is create new ones each time. And we can construct, we can use these types. So we can use record types, discriminated unions, and tuples, which we're going to meet as well in the next section. Tuples are basically exactly the same as they are in C#. We can combine them in any way we like. So we can actually build quite complex data structures out of quite simple structures. You know, we've got very little here. You know, we haven't used any inheritance or anything like that. It's all fairly simple. So just the same as we can compose types, we can also compose functions. So this is the other side. We have one function there, and here I'm going to take three functions. So I've got three functions called get purchases, try promote to VIP, increase credit if VIP. Don't worry about what they do or any of that. All we're trying to do is how we compose them together. That's all we're looking at. So we're going to take a simple customer record type, which has an ID, a flag for his VIP, and credit as decimal. And we're going to look at how we join them together. So get purchases takes a customer and returns a tuple of customer and decimal. Try to promote to VIP takes a tuple of customer and decimal and returns a customer. And increase credit if VIP takes a customer and returns a customer. So as long as the output from the previous function matches the input to the next function, we can compose them together really easily. It's very simple. It's the same as C#. You know, if you want to combine functions together, that's what you need to do. But how do we do it? Well, one of the ways of doing it is the imperative way. So we take the customer as a parameter. We then run get purchases and set it as a result. We then take the result and pass that as a parameter to the next one. Slightly long-winded. Probably wouldn't write it this way anymore, but it works. Second way, C# style. So effectively nested functions. Now I find this really hard to look at now because I haven't written C# for over 3 years. I look at this and I have to try and work out what it's doing. Whereas you're probably looking at it and thinking, oh yeah, I can see exactly what that does. I actually find this quite difficult to read now. So, but we've got some nice things within F#. So one of the things we've got is, that you might have seen occasionally, is the forward pipe operator. And most people look at it and think, what on earth's that? Well, actually, it's used for what we're doing here. So compose 3 takes customer, and what the forward pipe does is it takes the thing from in front of the forward pipe and passes it as the last parameter to the next line. So this might make, you can also write it like this as well. So what this does is it takes customer and passes customer to here. It then runs that. Then the result of that gets passed to here. and then the result of that function gets passed to here. So it's exactly the same as the previous two ways of doing it. But this has some advantages for us. Number one, the IDE is telling us what's happening at every stage. I can also run each stage individually, because I can run that inside the REPL. I can run that inside the REPL, or I can run all 4 lines inside the REPL. So if I do I just include those for now, and then I'll just run get purchases. And then I can run, oops, I need to run VIP as well to set that up. And then I can run compose 3 VIP, and I can actually have a look at what comes out. So here I've got a tuple of customer and decimal. So I've got a record of an ID of 1, is VIP is true, credit 200, and purchases of 80. So I can now add my next bit in, run that inside the REPL. Because that's the only bit that's changed, I only need to run this now. That returns the customer. So I can do it in phases. So rather than having to do everything in one go, I can do it as I go along. In this particular case, I could also use the double arrows as well. So the double arrows is actually the composition operator. So they're exactly the same. So all of these 4 functions will return exactly the same results. So if I just prove this, where are we? So if I run all those, I'll enter inside the REPL. So I'll run a VIP customer. I get a set of trues out of there. If I run a customer that's going to get promoted to VIP and added some extra money, I can run that. That all works exactly the same. So I'm using all of the different functions, and the same for not promote as well. So that all works really easy. So that's really simple. So that's taking simple types. So the other thing that I really like about F# is collections. What we can do here is I'm going to load some data from a file. Except I can't because I've copied it. Oh dear, right. Okay, I'm going to need to cheat here. I've just realised I've copied the code over and not copied the file. So this is exactly the same code. So I've got a simple record type again with data. So let's have a look at the CSV that I'm going to load in. Go to that. So this is fairly similar to the data that we were looking at previously. So it's got a header row with information, and then it's got data to go with it. So read from file. So the customer, all I've done there is to try and match it to the data that we're going to get out of the CSV file. I've got a simple function that's going to return a sequence. So a sequence is a bit like it is IEnumerable of T in C#. So we have 2 of the main types. We have an array and we have a list as well. So read-only list. But this is a sequence, which is, as I said, IEnumerable. So this is going to, this is an iDisposable. So exactly the same as using in C#. We don't generally use the new keyword, but we do with iDisposables. So this looks basically like you do for C#, except that it's inside a sequence expression. And what this is going to do is just create a list of data. It's going to read the data in from the file. And then I'm going to parse it. So I'm going to take that line in, I'm going to do a split. And then this funny little character here, which is a square bracket and a bar, that's what we use for arrays. So we have the squiggly brackets for curly brackets for sequence, the square bracket and the bar for array, and the square bracket on its own for list. And what I'm doing here is pattern match. So just like we did pattern matching earlier, we can do pattern matching with an array. So I know that this array has 6 items in it. And what I can do is I say, if I can break that thing down, I can also get at the data as well when I look at the data. So it's going to look at a row. If it can split it into 6 bits, it will apply those values to those 6 labels there. And then we just work out, we just say if is eligible is 1, then it will say true, etc. Things like datetime.tryParse. So if you know your C# libraries, you'll know that uses an out parameter. Don't support out parameters in F# at all. What it does is automatically converts it into a tuple. So it converts into a tuple of success or failure and the value that you get out of it. So rather than having an out parameter over here you get a tuple instead. The OK and the error are to do with the result type. So result type is a discriminated union again. It's a really simple thing. And this is either a success, which is a customer, or it's a failure, which will be in this case, it's a string. So I'm just going to return an error message. So what I'm going to do is I'm going to use path.combine. There's a built-in helper method called source directory. That just gives us the path for the source directory. There's a folder called resources, which is that. And then the file is called data.csv. I'm going to read the file. So it's going to use the forward pipe. It's going to pass the path as the parameter to read file. So read file is this. So that's just going to read the data. I'm then going to skip 1 row because the first row is the header row. Then I'm going to use map. So map is like select in C# inside link. So this is the thing that does converts from one format from one structure to another structure. And that's just going to use the parse function. And then we're going to iterate. I'm not sure what the equivalent is in link for that, but that's basically, we're not going to return anything. So this funky keyword at the end here, unit, so there's no such thing as void in F#. So anytime you don't return something or you don't take a value as an input, you can't just supply nothing. What you have to do is supply unit. So it's a built-in structure, but it doesn't mean anything. It just means there's nothing there. But it just means that we will automatically supply a value back. So I'm going to run all that in the REPL again, and then just to run it, I call the function with open bracket, close bracket, that's unit, and I've got some data. So wildly exciting, but things like lists, sequences, arrays, handling collections in F# is fantastic. It's really easy. I've barely scratched the surface with this. So one last thing before I stop this section is So this is the code on the left-hand side. This is the code from the third of the examples that we did with the eligible registered customer, etc. in F#. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21 lines, 20 lines of F#. Anybody want to guess how many lines of C# there are across here on the right-hand side that's the equivalent of it?
In fairness, that's not a fair comparison, though.
I know it's not. I'm deliberately.
Someone had to say it. Someone had to say it.
It's fair in that it's fair in that it is generated, but even then, I mean, even if you allowed a certain amount of leeway, so there are over 1,000 lines there. So even if you allowed, even if you said it was 200, it's still a magnitude smaller. So the thing is, what this has to do things like equality checking. So F# records are use structural equality. So everything in F# uses structural equality rather than reference equality, and it does make a big difference. Right. So that's the end of part 1. So I'm going to give it a couple of minutes, and then we'll go on to part 2. If that's okay.
Sounds good. I'm just. Are
there any questions in there that I need to answer?
I think people have been answering them for you on your behalf.
Okay, that's good.
A long stream of chats. Paul said, challenge in the room for anyone that reckons they can write that really small in C#. And I was about to reply saying, oh, no. I was about to reply saying that I want to listen instead of code, but actually, if we're on a break, I'm tempted. I reckon I could write that pretty small in C# with using the latest language features.
Yeah, you could do, but I still think it's going to be the best part of a magnitude out.
Can I ask a quick question, Ian?
Yeah, of course you can.
I'll just start my video again. Yeah, I read your book, which was great, and stylish F#, and I know stylish F#'s being updated soon. Have you got any plans to update your book to the latest F#6, etc.? Not trying to put you on the spot, just curious.
Yes, it will get updated at some point, but I haven't picked up F#6 yet or .NET 6. But yes, once we do that, it will get updated. It has to.
Yeah,
I don't think it's. Although there's not that much difference, there are subtle differences. So I just think it's definitely got to be done. So all the other thing I could do is just is open source the book and then let the community fix it.
Yeah, that would be good.
I'm not precious about it.
Yeah. But I'm definitely a F# fanboy. So I actually thought I thought this was actually a whole F# meeting. I didn't realize most of the people here are C# people. But you're preaching to the converted with me, Ian, that's for sure. And I'm a long-term Java programmer as well, and F# has really made me question the validity of the whole object-oriented paradigm. I think it's just become way too confusing and overly complex, and added, thousands of lines of unnecessary code to complex enterprise systems that are just overly complex now. That's my personal rant.
I must admit, I was finding it harder and harder to work with C#. It wasn't the language so much when I stopped. It was more how much I needed to know. How much You know, I had to know design patterns, and I had to know entity framework, and I had to know all sorts of other things. It was just, and plus when you started writing code, the amount that I needed to hold in my head at any one time to know what was actually running was really difficult. Whereas in F#, if I can't see it on the screen, I don't care about it.
Well, that was the beauty of C. You can memorize all the keywords. They deliberately didn't have a lot of language keywords for that reason. You can actually keep everything in your memory, which is why I've always liked it. But Java, I haven't done a lot in C#. It's mainly been Java, so similar sort of thing. But just Java's really modernized the last couple of years. So, but even so, it's more the object-oriented paradigm that took over the world that I'm questioning now, which I didn't before, after seeing functional F# through my first functional language.
There's a lot of validity in object-oriented programming. A lot of the ideas are pretty much the same. I think it's the mysticism that seems to go with it. The fact that you have to get, you have to know which patterns to use in which places to make it stay on the straight and narrow. As the thing gets bigger and bigger and bigger,
exactly. That's a problem.
It gets harder and harder and harder to manage everything. Whereas F#, it's very much it's basically as your program gets bigger, it just gets bigger.
Yeah, that's what I'm saying.
The complexity is always in the small. The complexity is always in the small, never in the big.
That's right. No, I'm talking about the big enterprise applications. It almost becomes indecipherable. I've written a lot of ERP software. In fact, I owned a ERP software company for many years, and our application just got way overly complex, and I know one person could understand it. That's for sure now.
So why do you think they changed the motto from functional first to powerful, enabling? I don't know what it was.
To robust, succinct, and performant.
Yes.
I think there's a lot of there's some odd things said in the last week that I've heard about making F# normal, as though it's abnormal first. I think it's just to take away when people say functional program, then they immediately think of monads and category theory and all the rest of it, and you really don't need any of that. That's, in fact, it's a hindrance in many ways with F# because it just doesn't support lots of it. You're better off thinking, this is F#, this is the language. I can produce really good code by sticking with the things that it does well, rather than being a good functional programmer.
So I'm a little bit F# fanboy, but I get a little bit concerned when I hear that. Not that we shouldn't appeal to people, but I saw the take that Facebook took Reason, their kind of ML language, F#-ish language, and I'm totally disagreeing with that direction. I would drop out of F# if it went that direction. Basically, they made it look like C, and it looked kind of like F# before, and I got saddened when that happened. So I hope it remains this style of language is called ML language.
Yep.
I want it to stay that way.
Yeah, I'm sure to a certain extent that it will. I think it's there are enough people using it that like it. I don't think it will move from where it is. It won't suddenly become C#.
One of the things, I don't know if you mentioned it, but in F# indentation matter, right? So one thing they changed in Reason was that they went away from that and introduced brackets everywhere, which I felt was a mistake. I like it this way, personally.
Yes. Yeah, I agree. I mean, but it's the same with, they're finding nice ways of doing C# now. So things like the global namespaces. So taking away things that aren't really necessary. I think it's a C#'s a bit of an odd one at the moment for me. They're adding more and more and more, and it seems to be going away from where it was originally, but they're also improving it in other areas.
Yeah, so here's my, nobody asked me for my opinion, but I think in C#, sometimes hear about C# is saying there's no need for F# because we are stapling all this feature on top of C#, and sooner or later C# will catch up. But I don't think it will ever become as good functional language because C# is an object-oriented first, in my opinion. And it's fine, that's fine. But stapling features on top of that doesn't mean you become everything. Then it becomes C++, which is a multi-paradigm weird language, which I like, but it's weird.
Yes, right. I need to jump back onto this. Dave, if you want the code, it's on GitHub. If you find IJ Russell on GitHub, there's a repository in there called F# for the masses. That's just off chat. Right. So next one, introduction to web programming in F#. So I'm going to use Giraffe. So Giraffe is a very thin wrapper, a very thin functional wrapper around ASP.NET Core. And basically allows you to use all the good bits of ASP.NET Core, but in a functional style. So it's a really nice thing to work with. If you want something more structured and more like MVC in many ways, then you can have a look at Saturn. And Saturn's a wrapper around Giraffe, which is a wrapper around ASP.NET Core. And if you want to go full on F#, you can have a look at the SafeStack. And SafeStack basically does F# for everything. So you can actually write JavaScript in F# with Fable, and it's pretty amazing to say the least. But it's I haven't really used that at this stage. I've played around a little bit, but we don't use it in production. So we just use Giraffe for what we need. So as I said, it's a simple little wrapper around F#. Creating it's quite simple. You've got two options. You can either install the template. So if you go to the Giraffe GitHub page, you'll find there's a template you can install, and you can do .NET New Giraffe, or you can use you can create something using the built-in templates. So the simplest one is to use the web. I'm not going to run it, but so if you do .NET New Web -lang F# and run that, what you'll get is a new web app in F#, and you get pretty much what we're going to look at now. So compared to what you get from the start, all we do is we add in add Giraffe to services inside the startup, and we also add in a use Giraffe to the app as well in configure inside the startup class. And then this is the thing that we're actually going to run. So basically, one of the core things that Giraffe does is it creates what they call HTTP handlers. And basically everything in the routing system with Giraffe is a HTTP handler. So things like the word get is a HTTP handler. The routing is HTTP handler. For a view or JSON, that's a HTTP handler. If all your authentication, it's basically middleware. So the whole of the routing system is HTTP handlers. And they're quite easy to write. So what we have here is, this is my web app. So I've created a module called handlers. So it's a bit like a static class, but it's just a module. And I've created a little handler function, which I'll come back to in a second. And then we've got the web app. So we go back to my use Giraffe here. That handlers.web app is just pointing at the routing. So all this is doing is determining what routes we support and what routes we don't support. So choose is a combinator, it's an OR. So what it does is it tries the first one, it says, is this a GET request? If it isn't, it will just go to the next one that's available. And in this case, it will go to a not found. If it's a GET request, it will say, is it the root? Is it just a forward slash? In which case, we're going to return a view. Is it forward slash API? In which case, we're going to return some JSON. Or is it forward slash API with a value in there as well? In which case, we're going to call a custom handler. So to run this, because it's .NET, I can just do .NET run. I'm going to do that just this first time, just to show that it works. And this looks exactly like all of your ASP.NET Core things when you run them from the command line inside VS Code. So I can just run this using Control and C. That's a view. Remember I said forward slash API. Let's return some JSON. And forward slash API Dan. And I get it some JSON back that says, hello Dan, how are you? So really noddy, obviously really simple. It's not designed to be anything particularly special. But that's it. So I've actually plugged all of those in. So the other combinator we've got here is what they call a fish operator. It looks really bad and looks really scary, but all it does is combines two handlers together. That's all it's doing. So all we're doing is, so routing is basically building a pipeline of middleware to eventually get to something that runs. If it can't run, it goes on to the next line each time. That's a really simple idea, really clever. There's also a much tidier version of this as well that's done outside of Giraffe. So somebody's written a different version that makes this even simpler. But it follows a similar idea. So a handler, what does a handler look like? So remember before we talked about we don't add the types onto things. When I write handlers, I do, because they're quite complex. So I tend to write the structures. So what this is telling me is that say hello name handler takes a string called name, but it also takes a next, which is a HTTP func, and a context, which is HTTP context, and returns a HTTP handler. So that's actually written the same as I could do. Sorry, I'll just copy this line and run it twice. Oops. Copy and paste isn't working particularly well today. So it's actually the same as that. But it generally doesn't get written that way. Most people, when they write their handlers, they do it like that. Funny colors. Okay. I think that's okay still. So writing handlers is really simple. We'll cover a lot more of this as we carry on. This is just to get us started. And now the view. So those of you that like writing HTML, sorry, this isn't HTML style. This is XML nodes. And this is basically a DSL for describing HTML. But you've already got one of those because that's what HTML is. HTML is a DSL for describing a web page. So why are they doing this? Well, there's some advantages with this in that it's, because it's all F#, it means that if you've made a mistake, the compiler will tell you you've made a mistake. But it also means that you've also got the full power of F# available. So anything you can do in F#, you can do in these views. So you can write functions in the middle of all of this. It's really powerful. So the basic structure of this is each one of the HTML verbs has two lists attached to it. So the first list is the styling list, and the second list is the data or the properties that goes with it. So if we take a look at this P as parameter, sorry, this paragraph, isn't it? Yeah, sorry. This paragraph, we've got, so in the first bracket, we've got a class and some CSS. And then in the second one, we've got the content, which is a string. So you get used to this fairly quickly. It's very different to most of the other types of systems that you have, things like Razor, you know, which are mainly HTML with other bits inside it. It's just a different style. Once you get used to it, it's fine. So that's a really simple idea. So you get it started and you can easily get views and handlers and all the rest of it. So what I'm going to do is I'm going to close this one and start another. Close the folder. All right, so this is a slightly more complex one. This is an API. So what I'm going to do is extend the API a little bit. So we're going to write a to-do API. Really simple. So the first thing to notice is, if you look on the left-hand side, those of you who are used to C# and everything being in alphabetical order, note, not only is F# ordered inside a file, F# is ordered inside a project as well. So you have to order the files differently. So the most important function in an F# project is always the very last bit of code in the last file. So the entry point is always the last point, is always the last bit of code in the last file at the bottom. So that's where you start from every time. So in this case, we've got a starter. We've got some other bits and pieces here, but I've added some other things in here. So we can still do dependency injection. So what I've got here is a simple to-do data store. It supports objects, supports interfaces as well. I haven't bothered with interface here. There's no point. So let's go and have a look at the to-do store. To-do store is an object. You can tell it's an object because you've got a type and then you've got brackets next to it. So you can have constructor arguments as well, but I didn't need one here. The reason for having an object is that I have an internal data structure that's mutable. So a concurrent dictionary is a standard .NET concurrent dictionary, but I'm not exposing it to the outside world. All I'm doing is exposing it via some functions, via some member functions. So I have a to-do data store.create, update, delete, get, and get all. So those of you that have been following some of the controversy about the dot in array syntax, this is what they're talking about. So data.id. So in most languages, you don't need the dot. And as of F#6, you don't need the dot anymore either in F#6, but we need it here for this. I'm just going to point that out for completeness. So to-do is a really simple record again. So it's got an ID, a description, a created date, and it is completed. Flag. I then have a to-do module, which contains all of the handlers and the routing for the to-do handler. So in this case, I've got a get that does my my viewer to do, and also the viewing the list. I've got a post that that does the create, a put that does an update, and delete that obviously does a delete. So if I go back to startup, how I add that into the main routing is I can use the subroute function. So the subroute says, if I send in anything with API/to-do, then go off to that routing handler. And that's what it will do. And everything else is pretty much the same as it was before. So if I go and have a look inside the to-dos, so if I go and have a look at the view to-do handler, so all I'm doing is I'm getting the service from the context, just the same as you do in a normal ASP.NET Core app. And then I run the function against the store to get my to-do, and then I return some JSON. Really simple, really clean. And all of the handlers are like that. So obviously I could run this, and I could run Postman against it and show you how it all magically works, but I think you all know how an API works. I'm not going to bother going and showing how all that works. You've got the code anyway, so you can run it. It's quite simple. So I'll move on to the next section, which is onto views. So we're going to push the view engine a little bit further. Just load in. You'll notice that I'm using VS Code. So there's a plugin called Ironide for F#. It works really well. To be honest, you don't need a fully fledged IDE to work with F#. You know, I know people who do production level stuff who use VS Code, and they're really happy with it. So we've actually standardized on Rider, but it's not because VS Code isn't good enough. It's just because we decided that that we wanted everybody to use the same IDE just to make it easier to work with. So let's have a quick. So the thing about Ironide is that Ironide is available via the F# extension on here. On the left, you've also got the original Explorer view as well. So you can see here that I've added a webroot folder, and I've added two files called main.css and main.js. These aren't my, I've just copied the CSS and the JavaScript. I'm not, I didn't see the point of writing loads of it. So if we have a look at startup, so we've still got the same API, but I've changed here the route for the HTML views. So I've now got a module called to-dos and views, and I've got a to-do view and a to-do list as well. So I've obviously still got my to-do store. If I have a look in here, so this is my to-do list. All I'm doing is just creating a manual list, saving going back to a database. I'm just going to build up a list from scratch and just use that. Where do I need to go? I need to go to. So I can nest modules if I want to. So I've nested the views module here, so that the view engine is only available inside the views module and not outside. So what I've done here is I have a shared views section, and that's where the master page lives. So the master page is a function that takes the message, which in this case will be the title of the page, and the raw content that goes in the middle, that goes with the body as well. So I go back to my to-dos. So my to-do view takes a list of items, and then this is building up the structure that we're going to work with. And all I do then is I pipe that data into the master page. So we're using the forward pipe all over the place. So I'm passing all of that XML node that's in there, that's here, as a second parameter. So it gets passed in at the end here. And then I've got a little helper function here that's just creating a simple control. And then obviously I can just use those. So I'm just doing a for loop here in my list of items, and I'm just showing the to do. So nothing special. It's really simple to use. Once you get the hang of it, it's really clean. And obviously the fact that it compiles generally tells you that it will work, which is a good thing. I've got to show you this because it's absolutely hideous. So again, all I'm going to do is a .NET run, just exactly the same as you do elsewhere. I'm just going to run that one. What do you think about that then? Think about my styling. Professional software developer.
It's better than mine.
Yeah, it's not
Beautiful.
Thank you. Yeah, so one of the things that I want to do with wanted to do with the book was to add another chapter which actually plugs all this in, so you get a fully working thing. But obviously, Giraffe's going to change quite a lot with F#6, with the new with the new task stuff. So we'll see. Okay, I think that's about as far as I want to go. So Giraffe's really simple. If you can do ASP.NET, then you can use Giraffe. One thing I need to cover is so use static files is exactly the same as before. So if you want to use static files, you need to use that. So that's exactly the same as C#. And then setting up the web route is exactly the same. So you just, oops, didn't mean to do that. You set up a content route, which is wherever the current directory is, and then the web route is just off the content route, and you set that up to use web route. That's how you'd easily access the CSS and the JavaScript. So it's pretty much exactly the same as ASP.NET Core. So that's all I'm going to cover with Giraffe. It's really good. Once you get your head around F# programming, it's really fast, really efficient, and you can get stuff done very quickly. We are shoving a ton of data through Giraffe. It works really well. It's admittedly, that's not all Giraffe's fault, or all Giraffe's success. A lot of the success of F# on the projects that we run is the fact that the .NET Core is fantastic, as is ASP.NET Core. They've made fantastic progress over the last 3 years since 2.1 came out. Speed has improved beyond belief. The load as well. If you look at how much load you're putting on the system, every time you put a new version of .NET on, the load drops, but you still get the same level of performance. It's fantastic. And F# just sits on top of that, and we get a nice functional way of running on top of it. We don't have to do a lot of the jumping through hoops that you do with or have had to do with ASP.NET Core. The routing's really clear and easy. I'm actually really looking forward to seeing what happens with the new minimal API stuff and where that goes, because that's quite interesting.
Yeah, I wonder with that, with C#, and this is again shows where F# kind of shines. In C# with a minimal API, your main method now doesn't need to have a class, like top level statements, I think it's called, which is nice in one file, but kind of you want to be able to split that across multiple files with this minimal API, but then you've got to resort to classes again. So it's kind of, it feels like it's okay for a small demo, but in real life, maybe not. Yeah.
I can certainly say the F# version works really well. Yeah,
I think they're selling F# with the minimal API, to be honest, because you get to the point when you don't want classes in other files, and you think, oh, actually, maybe I should give F# a go.
That'd be nice. I'm not sure that'll actually work out that way, but if it does, that'd be brilliant. Yeah, more people jump into F#, the better. This is all I can say on that. So, okay, so that's the end of part 2. I'll bear in mind what the time is. I think I'll go straight on to onto part 3. Where are we? Right, PowerPoint. I'm not going to risk running the... Actually, I might try it, see what happens. Well, that actually works. Teams doesn't. Teams just blows up for me running PowerPoint. Okay, so this is pretty much what I did for the F# exchange. Some of it's changed a little, but not much. So apologies if you've already seen this, but obviously the title's changed, but the content's going to remain pretty much the same as I did for that. So I work for Trustbit. We were called Software Park up until about 4 or 6 weeks ago. Can't remember exactly when it changed, but we are the same company, but we're just called Trustbit now. It's just the fact that Software Park was being used by other companies, and unfortunately, if we want to start on our road to global domination, then we need to have a name that's fairly unique at this stage. So that's why we are what we are. So, tiny little bit about me. I love F#. I love functional first programming as well. I'll be happy to admit it. And I really think that I'm too dumb for modern C#. I really find it really hard to get my grasp of it. And as we've already seen, I'm the author of an ebook. So a little bit about that book. It's available on LeanPub. It's for $12.50 recommended price, of which $10 is the author's royalties. And I'm giving all of the royalties to the F# Software Foundation. So I think I've sold 220 something books so far. So it's around $10 per book has gone to the, most of that's gone. I haven't got the royalties for the last bit yet, but yeah, certainly the best part of $2,000 has gone to the F# Software Foundation to help them support the language and all the stuff that they do as well to help the community. So, quick agenda: what we're working on, why did we choose F#, and what is working in F# like. So we started just over 2 years ago. There were 3 of us in a team, 3 senior developers, as in experienced developers. I'm old, the other 2 aren't, but they were quite experienced. So our job is getting GPS data from providers, going through a basic pipeline and shoving the data out to another team who do ETA calculations. So they basically work on transports. So delivering goods from A to B via C and D, and they can work out when things are supposed to be at certain places. So it's quite an interesting domain. It sounds quite simple. Actually, like all simple domains, it has so many edge cases that it's quite complex. The other interesting thing is GPS. You'd have thought there'd be a standard. We now talk to 250 different providers, and there are probably 230 different styles. The data is basically the same, but how they structure it, how you get it, is completely different in all of them. It's a bit of a nightmare, to be honest, in some cases. One of the requirements was that we had to live on Google Cloud. We had no choice in that, as customer drove that. We're using Docker because we went with .NET, and Google Cloud doesn't support .NET for most of the things that we want to do. There are now .NET functions, but they're still using 3.1. They are going to move to 6 at some point soon, but we've basically used Node for our cloud functions, and that seems to work quite well. Most of our cloud functions are just converting from one format of JSON to another, so it's relatively simple usage. So we're now a team of 8. We now have what we call pull providers, so there's 250 of those. And basically, we make a request every 10 minutes to them. We get some data, we shove it through the pipeline. We also have push providers, and basically we open a pipe and they shove data through to us whenever they want. We have a couple of APIs, as said, written in Node, and they're basically for customers to send data to us who don't want to use, who do their own aggregation, but want to use the ETA system. And we also have a mobile app as well that's used by drivers that don't have GPS. So the processing pipeline's got much more complex over time. So we do things like deduplication, so we don't send the same message twice. We do a lot more validation than we used to, and we also manage ownership as well of signals. So we do lots of little bits and pieces now. So the recipients of signals, we still send to ETA. We shove out to a couple of APIs as well. So people are interested in using us as their data aggregator. So we will receive data from their providers, do all the work for them, and then push data out to them, and they can then use their own transport planning system. We shove all the data out to Data Lake, and we also have a product called Fleet as well, and that's basically a management UI. So that's a full-on Giraffe app with forms and everything. So that's our view of the data that's passing through the pipeline. So another requirement is that we use Terraform, and that seems to work quite well. I think we'd have been happier with Pulumi, but Terraform it is. It seems to work okay. Lots of YAML files all over the place. So give you an idea of what we're doing. So we are 24/7, 365. Transports never stop. There are always people delivering stuff all over Europe, 24 hours a day. We're currently delivering nearly 9.5 million signals each day. That means that we store nearly 9.5 million signals every single day. So we only store 30 days, but 30 days of nearly 10 million is still 300 million signals. Still quite a lot of data. But the data we're most interested in is the latest. So obviously, as data gets older, it becomes less useful. We're currently dealing with about 65,000 devices or so every day, unique devices. And as I said, 250 providers or so, all completely different. And there are 5,500 signal sources, so sets of credentials for us to be able to connect to providers. So every 10 minutes, we're basically making 5,500 calls using HTTP client across the various providers. It's quite an intensive system. It's obviously not like finance systems, in that things have to run in milliseconds and all the rest of it, but it runs plenty fast enough for our needs. Data gets through the system pretty quickly. So out of those people that started, the 3 people that started, there was me, there was a guy who'd done quite a bit of Scala before, and there was a guy who'd done mainly C# before, and now we've got 5 other people. We've got a product owner and 4 other devs, 5 other devs on occasions as well, and they're all basically C# devs who cross-trained. So we have experience of actually taking people who've never touched F# in their life, walk in, and within a relatively short space of time, they're producing production code, and within 3 months they are completely good developers in F#. So it's quite an easy thing to get up to speed and become I won't say an expert, but become very productive. So one of the reasons that I wrote the original blog posts was to get people to look at what we actually do. And if people could work through those blog posts, that's over 90% of what we actually do. So anybody that's read the book covers about 95% of what we do. So that 167 pages in the book is what's needed for a large production application in F#. Now you compare that to, I don't know what the essential C# book would be like, but I'd imagine it'd be slightly bigger than that. So why did we choose F#? Strangely enough, I wasn't the person that drove this. I obviously wanted us to do F#, but I'd have been quite happy doing Scala, to be honest. Anything but C# would have probably been my answer at the time. Basically, we wanted something that was functional first. We all wanted to do something functional. We wanted something that had a high signal to noise ratio. So we didn't want lots of extra brackets and all the rest of it. So closure was out, even though it's a good language. Strongly typed, again, closure then goes. So we actually stuck to, we had to have something on .NET or JVM. So that was a condition for us. We also wanted something easy to learn and understand. As I said, .NET or JVM. So from there, we ended up with 3 core options. So that's F#, Scala, or C#. We dropped C# almost immediately, and we basically built a little prototype in F# and one in Scala. And we had a look at, so I did something in Scala, and the Scala dev did something in F# to see how they could work with the language, and we decided to go with F#. So that's why we did that. So what have we found? Well, one of the things we found is that talked about it earlier a little bit with the with having to know in C# you have to know so many things to keep everything clean and tidy. You have to know which patterns make sense in which cases, and all the rest of it. It feels like you're having to work really hard to push it up to that thing at the top of the hill, which is success. But then you have to work really hard to keep it there, because if you don't keep the standards up, it falls off. Whereas F# was completely opposite. F# was you start writing code, and as the code becomes more difficult to work with, it's basically telling you that you're not doing it right and pushes you back on track. So you know very quickly that you're making mistakes, and you can't write thousands and thousands of lines of code and then suddenly realize that something's gone wrong. You know fairly quickly each small function, because you're working on small bits. Every time you're finding bits hard, it's basically saying do it the right way, and when you do it the right way, it all seems to work. Type system. We saw parts of the type system earlier on in the first part of this. So as I said before, I don't like writing tests, but also I don't like bugs. So the best way of handling bugs is to prevent them in the first place. So if things can't happen, if they can't physically happen, you're not going to get a bug doing that. So things like null reference exceptions. Now, we do occasionally get null reference exceptions, but that's because of handling data from the outside world. You're occasionally going to get those as data structures change. But within our F# code, we don't get null reference exceptions anywhere. So one of the things that the F# and functional languages in general seem to be quite good at is making illegal states unrepresentable. So the data structures, while simple, are very expressive, and they make it easy to build really clever structures that are fairly lightweight, that solve a lot of the problems. Adding an extra type often solves a lot of problems. And once you get into it, it's a fairly nice thing to work with. It's also, because of the nature of F#, because you're not writing tons of code, it's very easy to try lots of ideas out. It's much harder to do it in a language like Java or C#, where you have to write a lot more code and have to compile it and then run it and see if it works. So just being able to run things in the REPL just makes things a lot easier for us. The immutable data is a fantastic one. People immediately say, doesn't that make it really slow? No, you'd be surprised how many times you actually need mutable data. It's very rare, and things like immutable data, things like collections, you think they're quite slow, but they're not, because they build really fast data structures for immutable data. It's there are people who spend all their time just doing that, and it works really well. Yes, if you've got billions of records, it is going to be slower than mutable for lots of things. But I don't know many people that handle billions of rows. Most of the time you're not going to notice any difference. And the fact that it's immutable means that if you've got lots of data, being able to shove computations out to different cores is really useful. You don't have to run everything synchronously. You can run everything asynchronously and also in parallel. So it's a really powerful thing. Say no to nulls. So null reference exceptions are the bane of C# applications. I've tend to find you end up with lots of checks all over the place. Obviously, it's getting better with some things, with the way that that nulls are represented, or nullable types are now represented. But it's been built into F# from day one. So people who work on it know that we just don't have nulls, and you accept that that's how it works. And it gives you a level of confidence that your code will always work. And finally, statically typed. I know a lot of people like dynamically typed. I sort of understand the ideas behind it, but I love the fact that if it compiles, chances are it works. That's a fantastic thing for me. I don't have to worry about it. One of my problems with JavaScript is the fact that I don't know if it's going to work or not until it runs. And the other thing about the type system, as I sort of implied earlier on, is the fact that you can model quite complex domains in one file. You don't end up with 50 files with classes in it and trying to work out where all these structures are. You can actually build everything in fairly small, fairly compact things all in one file, and it works really well. Doesn't say you have to build it in one file, but you can. We've got a roadmap. So this book, that's my quote, the game changer for C# devs. That's from 2018. I believe it even more now than I did then. This book by Scott Voloshin, Domain Modeling Made Functional, basically explains how to build the types of domain apps that people build everywhere in a really clean, clear way, and gives you a set of structures that you can work with to do all of this. It's if you haven't read it, buy it and read it. It will change your life. So what's it like working in F#? So the areas I really want to cover are things like tooling, data processing, updating, code structure, adding new features and extending, and finally the last one, the recruitment and onboarding side. Because obviously it doesn't live in a vacuum. You can have the perfect language, but if you can't get people to work on it, then there's no point using it. So tooling, we use JetBrains Rider. There are occasional times where we use VS Code and Ironide. Certainly when I write handlers, I write them in VS Code and Ironide, and then I'll copy them across to the main app. So I'm quite happy to run like that. That works really well. I'm interested to see what VS 2022 is like with F#, particularly with it being 64-bit. Be interesting to see. You don't need a heavyweight IDE to work with F#. You don't need a resharper. You know, most of the things that you do, because everything is separate, you don't forget things like, because of the way the compiler works, that it's top to bottom, you don't really get circular dependencies. It's quite easy to just copy and paste things from one place to another. You might have to add in an open statement, a using statement, occasionally, but that's about it. It's much easier to do than with C#. We make a lot of use of F# Interactive. I can't remember the last time I debugged anything. I was thinking about it before the F# exchange, and it's got to be at least 2 years before I've since the last time I actually debugged anything. I actually put a breakpoint in. It just isn't necessary most of the time. That's not to say that people on my team don't debug, because some people do, because it's habit and because that's how they've been taught to solve problems. But over time, they learn that they don't need, that they can trust not to have to debug something. So we use Giraffe and obviously ASP.NET Core. Giraffe has been a fantastic choice for us. As I said, it scales really easily. We've not reported any bugs on it because it's just a thin wrapper. There's actually not that much in there, but all the things that we've ever wanted to do, it does. We've not looked at it at any point and said, I wish it did this. It's always been really good. And the other one that we use is we have a great big Postgres database, and we use something called Mpgsql.f#, and that's just a simple. That's basically a thin F# wrapper around the Postgres driver. If you like things like Dapper, there's Dapper F# and sort of things like that. There are lots of data access things available in F#, but we just use this one. It works really well for us. It uses the forward piping that we're used to, so we can actually build things up nicely and then just run some SQL. So that works really well for us. Data processing. So we have to deal with CSV, JSON, and XML and SOAP. So there are lots of ways of doing that in .NET. So there's type providers, which you've not got in C#, which give you typed access to data. So you basically pointed at you basically set it up, you give it a sample file, you said this is what the data is going to look like, and then you provide some data, which could come directly from the web or could be a file. In our case, it's the web. So we have, so we'll get data down and it'll just get typed data out of it. So you don't need to do anything else with it. It's all done in one line. And they're absolutely fantastic. You won't ever get them in C#. The compiler just won't support it. Other than that, we use Csv Helper, I think it's called. Is it called Csv Helper? I can't remember what it's called now. Yeah, it might be. That's really good. Obviously, we use things like Newtonsoft for JSON. There's an F# helper as well that sits on top of that. We use the actually no, we've moved away from Newtonsoft. We've moved to the standard text JSON thing that's in there. We have looked at some of the other providers as well. So there are some F# specific ones that allow you to serialize and deserialize the F# types much more nicely. But we found that everything that we've used generally works quite well. We're quite happy to live with any of them, to be honest. Interop's an interesting one. So any time that you deal with the outside world, and by the outside world I mean anything from the BCL or C#, you have to be careful that what you get returned isn't a null. So there's lots of stuff built into the option module to allow you to convert data from elsewhere into options to return some or none, so we don't get nulls. And the converse as well. So when you want to convert something from F# back into something that can be used outside in other languages, then you can convert from the option to a standard .NET nullable type or a standard C# object. We also do some protobuf stuff as well. All the protobuf stuff works with F# perfectly well. As I said, all the JSON stuff works really well as well. Handling updates. I'm a bit dubious about this one. So upgrading so far has been really easy. So upgrading from 2.1 to 3 and 3.1 and 5 have all been painless. I'm wondering if 6 is going to be a bit more, because they've had more time to work on this, and there seem to be more things in .NET 6 than there have been. So it'll be interesting to see what happens. But obviously, we've also got to then upgrade things like Giraffe, so all of the other supporting DLLs that we've got, all the other supporting libraries that we've got, we obviously need to wait for them to be upgraded to .NET 6 to make sure that they work properly. One of the things we do use is we use Packet. So we don't use NuGet directly. What we do is use Packet, and what that does is it manages the NuGet libraries for you and makes sure that you only have one version of each package on there. So instead of having clashes, which you sometimes get with NuGet, Packet stops that happening. So that works with C# as well. So you can use that independent of F#. You know, that works really well. So that's worth looking at. And I'm looking forward to task support. So we already have async in F#, and we already have task available through Ply, and there's a another third party thing as well that supports task. So task is async await. So it's exactly the same thing. Code structure. So one of the nice things about F# is that we can make things more domain centric. So we don't have to. One of the problems I've seen with Java and C# is the fact you end up looking at a code base and thinking, what does this code actually do? Because it tends to be very technical. It tends to contain things that describe the system that it's working on rather than the domain that it's supposed to be supporting. So sometimes you actually have to look at the code to work out what it actually does. So one of the nice things about F# is that it tends to be the opposite way. It tends to be very much easier to just write things in a code-centric way, in a domain-centric way. One of the things that we do is have a clean separation between types and functions. So you can add functions to types. So a record isn't just a data structure. You can actually add functions to it and properties to it. We don't do that. Part of the reason, and certainly if you look at the F# code base, they don't do that either. So things like option, you know, they don't add all the functions to the type. They have a separate module and then use the module outside of that, and that's how we've done it as well. I like the clean separation. I like the fact that that types are things that are used by functions, and functions transform one type to another type, and you basically create types as dumb data in effect, and that works really well. So compared to an object-oriented system where you'd have state and behavior in the same classes, we tend to go completely opposite and have a very clean separation between state and behavior. So they're two totally different things. So make use of modules to separate your code out. Obvious bit, put code that changes in the same file. It might seem obvious, but that's just the thing to do. You know, it's you don't have to feel precious about this. You don't have to have one file per class or anything like that. In fact, some of the size of some of the things that you write in F#, it would look really odd if you had 1,000 files all with about 5 lines in each one. It'd be really strange. So copy and paste for refactoring is generally enough. Yes, there are things like rename is available in the IDE, is inside VS Code. Other than that, you don't really use a lot. You know, you might add an open statement, so a using statement to get a package in. They're in the IDEs. That's quite simple. And the last one is this thing I was talking about earlier with the fact that I was finding C# harder and harder and harder to get with, you know, to understand, because I was having to hold so much stuff in my head to understand what each call was doing. Whereas in F#, it doesn't feel like that. I can just hold enough code in my head that all I need to do is think about the current function, because the current function is where all the work is. I know what's going in, I know what's coming out. Because they don't have, most of our functions don't have side effects, it's very easy to reason about each function. You don't need to step through code to work out where you are and go to different files and all the rest of it. It's a much simpler environment. So adding further features. So this is a quote from Sandy Metz. So don't write code that gets to the future, arrange code so that you can adapt to the future when it arrives. Because you're writing small functions and you're composing bigger functions out of small functions, this just naturally happens. You know, it's very rare that you make a decision that's not undoable, that you can't step back from. You know, there are times when you do things in object-oriented code where you make it, you know, if you want to put an abstract base class in there or something like that, it's quite a major move. You know, just that sort of thing just doesn't happen in F#. It's just much easier to reason about your code and think about adding new features as you go along. That doesn't mean you can't. You can just do it like the Wild West. You still need to think about where it goes and what's the best way of writing it. But it's a much simpler environment to work in. Collective code ownership. So we don't have, although we have people who are sort of responsible for certain areas, we make it so that everybody can read the code. So the big thing for me is this one, which is, will I be okay maintaining a piece of code? So when we do pull requests, we don't spend hours looking at it, looking at various design patterns and all the rest of it. What we're looking for is, number one, does it work? And number two, if I came back to this in 3 months' time, would I still understand it? And it's very rare that we've had a piece of code in a pull request that you can't look at and say, oh yeah, that's really simple. You know, you look at some C# code, and if it's not been written well, it can be very difficult to read. Certainly for a second person. That's, you know, it's my opinion on that, but certainly that seems to hold true for us. We do generally write simple code. So getting people on board. So the first thing is that when I started learning F# in 2010, there was very little out there. You know, there were certainly things available, but they were very high level in a lot of cases. A lot of people there seemed to be more experts than beginners. And all of the blog posts were designed for the people who'd been working on it for 3 or 4 years. And there was very little out there for people wanting to get started. Now there's a plethora of stuff out there, you know, whether it's things like Isaac's book, Stylish F#. I'm trying to think now. Obviously Scott Voloshin's book. There's also Kit Easton's done a fantastic video as well, course on Udemy. That's really good. So learning is really simple. And the one thing I'll say is that anyone can do it. I don't think that there's this impression that F# really hard. It's just different. It's just a slightly different style of coding than what you've done elsewhere. When you break it down, it's actually really simple. But it's different to what you're currently doing. If you've been writing object-oriented code for 10 years, you're going to have object-oriented lenses on everything. And it takes time to think in an F# way. F# relatively, you know, if you look at the language, there's very little there in the language itself. It's how you write the code and how you run how you work with the code that's different than what you're used to in C#. So I was a fairly experienced F# dev when I joined. I certainly agreed to that. If you're going to start writing a project in F#, don't have a team of newbies. Have at least one person who does at least has some experience. There's a difference between writing simple stuff to try it out and actually having production level stuff running. But that's the same with every language. You know, I'd hope that nobody would ever consider writing something in a language that none of the devs had any experience in. That would be slightly difficult. So we use a functional first style. That doesn't mean what that means in effect is we try and use a functional style first, and if it's slightly more readable to do it in a non-functional style, or you need to use an object, then that's what we do. You know, we're not strictly saying you have to be a functional programmer to do this. It takes time to get from not knowing F# to knowing F# comfortably. So my reckoning is that by 3 months, you should be able to be very proficient at F#. You should be. All of our people are writing production code in the first week, with help, admittedly, but they are nonetheless writing production code. We try to get people up to actually running the system on the first day, and then it's a case of getting involved in things like the pull requests, and asking questions and pairing up. But you have to allow some time for people to get up to speed. They're not going to get there in one day, or if they do, what they're going to do is they're going to write F#, C# style, and if you can do that, stick with C#. So if you want to use F#, learn how to use F# properly. Don't try and recreate what you already do in another language. There's no point. C# is a great language already. So we publicize our use of F#. So obviously we've got a blog, and we put blog posts on there. I talk occasionally. We try and get involved in other things as well if we can. It's really good. There's a Slack channel as well that you can get involved in. And so it's great. The fact that you publicize it is great because people then start to come and talk to you about coming working for you. So we've been quite lucky in that every time we've wanted new people to come on board, there's always been people coming to us saying, "You do F#, don't you? I'd like to come across and do F#." So it's actually getting us a good load of people for a pipeline for recruitment. So there's a lot of stuff I haven't covered. And basically for that, I'm going to say it's .NET. And pretty much all the way across the line it is. So all the things that you haven't thought about, so things like it's still a solution, you still have projects in a solution, you still have console apps, library projects, etc. So there's all of those things are exactly the same. There are some exceptions to the rule. So I mentioned earlier about some of the UI technologies that just aren't F# friendly, and Entity Framework really isn't F# friendly at all. But most of the time it is pretty much that. So all the stuff like authentication, deployment, all those things it's standard .NET. So are we happy with our decision? We obviously can tell that I'm happy, but are the rest of the team? So these are quotes from the rest of the team, and yeah, they're all happy as well. So that's really nice. I couldn't find. I asked for negatives as well, and there weren't really any negatives that people wanted to put across. It was all being picky really. They all said it themselves. That's a quick summary. So we're working on a fairly big thing for GPS. We chose F# because it's really good, and it works really well for what we use it for. So thank you for that. There's as I said, LeanPub Essential F# is the link. If you buy it, all of the author's royalties will go to the F# Software Foundation. Even if you don't read that, join the F# Foundation. And if you do that, you enjoy the Slack channel. If you like learning about other things, not just F#, we have a blog as well, and we're trying to get more and more stuff on there. We've got some really good people doing data science, machine learning, and domain-driven design, and those sorts of things as well. And that's my Twitter handle, which is @IJRussell. And with that, I'm going to say thank you very much, and I'm going to stop sharing. And I've talked for the best part of 2 hours.
You deserve a beer. Thank you so much, Ian. That was amazing. I've got to say, with C#, I'd just love to get rid of the curly braces and semicolons. And I'm from a C and C++ background as well, but even so, I still want to get rid of them because I just realised how useless they are. And I'm going to buy your book as well because, obviously, it's going to be awesome. But also, I didn't actually realize it was going towards you were giving it away to such a good cause. So I'll buy that book tomorrow. The prize draw up at the start didn't work, obviously, as mentioned at the start, because it'd be some webhook. In fact, it's probably a null reference exception somewhere that's probably broken it. So
write it in F#. That will solve all your problems.
So what I'll do is, if anyone that wants to take part in the prize draw, I'll shove my email in the chat. Just send me an email, then I will. What I'll do, I'll write some code in F# that randomizes all those, so I can play around with F#, picks a winner for each of the prize draws. So yeah, in fact, let me just do that now. And that is my email. If you want to take part in the prize draw, just drop me an email, then I'll sort that out. And that's it. So if we normally, after the talk, anyone that wants to hang around, we have a virtual pub session where everyone can just chat about stuff. And so feel free to hang around. And thanks again, Ian.